Hey everyone, welcome back to my daily coding series. Today's day 62 of me coding every day. So I just tried to record revisiting CoinChange 2, but it's still pretty hard for me. So these problems are, I think I'm gonna take just a break from these dynamic programming questions because they are really challenging for me, and I'll definitely come back to them soon. Um, Maybe at some point I could revisit and try these hard problems again. But anyway, so today I wanted to try. I watched this video yesterday where this person was doing a bit manipulation problem, so I thought maybe it would be a good time to start with these because I always saw bit manipulation problems, or at least solutions to some questions in all the competitive programming stuff I've ever done. It was pretty common, and I also just like working with bits in general. So yeah, I've never really done a problem like this, so let's just try it. So it's called single number. So I'm expecting that we will have to do um, bit manipulation, obviously. So I think and is that symbol, or is this symbol, and XOR is this symbol. So if I said like print 0 XOR 1, that should give me 1. Yeah. Um, 0 XOR 2. So if I said 1 XOR 3, that should give me 2. Um, yeah. And it's just because, so if I draw it out, 1 second. Yeah, so if I just draw it out, if we have 2 in binary is this, 3 is this, and if we XOR that, we get 0, 1. So, no, I did 1, 3. So 1 is 0, 1. So if we XOR those two, we'd get 1, 0, which is 2. I'm pretty sure and, so what if I did 0, if I did 1 and 2, or let's say 1 and 3, is this the answer is 1. So let's think 1, 3 gives us 1. 2 and 3 would give us 2, right? Yeah. Okay. And then this OR, so if I printed 2 or 1, that would give me 3, right? Okay, so I'm going to just keep that in mind. I don't know if there's like bit shifting as well, which I think is like that. And I think that would shifts all the bits to the right. Yeah, so 2 is 1, 0. So if we shift everything to the right, it would just be 1. So what if we had 1, 0, 0? Or let's say 1, 1, 0. So that's 6. So if we did 6 and shifted it one place to the right, I would expect we get 3. Let me just verify that. And then we can also shift. Okay, can we shift to the left as well? I don't know if that's the syntax. So this would be 12, it's saying. So if I shifted this, be 8, 4. Yeah, okay. So it looks like we can also shift left and shift right. Okay, so that's all I know off the top of my head. And then we could also not. What's not? Is it this maybe? All right, I'm just gonna look up that quick. So Python bit not. It's the tilde. Okay, so if I said not 5, that would give me -6. All right, that's not what I was expecting. Yeah, I don't know. I'll just not worry about that for now. Hopefully I don't need it. All right, so you're given a non-empty array of integers nums. Every integer appears twice except for 1. Okay, so All right, so everything appears twice except for one integer. And then we want to implement the solution. Okay, so if we look at this, 3, 2, 3. So we have 3, 2, 3, and we want to get 2. What if we had, let's say, this number? How could we return that? So it's the and for this one, and then it's the or for these. 7, let me try this example. So we have 7, which is like that, right? 4, 2, this is 7. 6, 6, 7, 8. So 6 is like this, another 7, and then an 8. And then we want to return 8. So logically thinking with bits, if something appears twice, right, and it doesn't have to be next to each other either, right? Okay, so if something appears twice, maybe we should make it 0, and then when something appears once, so let's say we have this. How could we make this 0? I guess we'd XOR it, and that would get us 0, 0, 0. So what if we just continuously XOR everything, and then we'll get the thing that comes twice. So if we look at 3, 3, so we'd XOR 3 and 2, and that would give us 0, 1, and then we would XOR that with this 3, and that would give us 1, 0. So that works for this test case. If we look at the other test case, which I deleted, it was 0, 1, 1, 1. So we'll XOR that with 6. That would give us 0, 0, 0, 1. Then we'd XOR that with 6 again. That would give us 0, 1, 1, 1. So 7, 6, 6. Then we would do another 7. That's 0, 1, 1, 1. So when we XOR those, that would give us 0, 0, 0, 0. So I'm noticing that when we have pairs of things, it ends at 0. So we could actually tell if there was no integer that appeared only once, we could tell that if our answer was 0. And then we would XOR it, in this case, by 8. And that would give us 1, 0, 0, 0, which is 8. Okay, so what we're going to do is set my result to be 0. And then we'll say for num in nums, we'll just say result XOR equals num, and then return result. Okay. Yeah, so that's that one. So we can use XOR, because if a number appears twice and you XOR it, that means they're and if it equals 0, that means they're the same number. So if you XOR the same number by itself, it must be 0. So then whatever you're left with is the odd man out. All right. So we're at 10 minutes, so I'll try probably one more for today's episode. I thought that was fun, so we can do the next one, number of 1 bits. All right, so that's this one. Very simple. Let me just pull it up on LeetCode and make sure that works. But yeah, I thought this was pretty good. I've always wanted to try to do like these bit sort of problems. I know they can be faster as well, like with brute forcing and everything like that. Okay, single number. And then let me, I mean, I'm guessing it's gonna work. It seems just like that's the way to do it. I wonder if I could do this in list comprehension. So could I say, so for num in nums, res times equals num for num in nums. I mean, we don't really use a list at all, though. Can you just do this? Does that... Can you do list comprehension, not assign it to anything? No. Yeah, I don't think that's how it works. Okay. Okay. Yeah, so that's the first one. Okay, it looks good. Yeah, it looks like everybody got that solution there. Okay. So number of 1 bits. Number of 1 bits. All right. So let's check it out. And I could also maybe learn about signed and unsigned integers, as well as the not operator. Okay. You are given an unsigned integer n. Return the number of 1 bits in its binary representation. You may assume n is a non-negative integer. All right. So the way I would... So what is n? N is a... So if I print n, I would just... So is it... Am I given the binary representation? Yeah. Yeah. So... Wait. No, I'm not. I'm given 11, which is 1 plus 2 plus 8. So I'm given... So if I print the binary of n, then it should look more similar to this. Okay, so I want to get the number of ones. So I'm given a number, and I want to return the number of ones in its, the number of ones. So in this case, let's say I'm given 11. So this is 11 because it's 1 plus 2 plus 8. I want to get the number of ones in this. So obviously what comes to mind is you could just convert it to a binary, loop through it, and then get the number of ones. Yeah, but there might be some sort of mathematical thing. So what's the max number? It doesn't tell me. It fits within 32 bits, so I guess the max number would be 2 times 32. The max number would be 2 power 32 minus 1. So I'm thinking, we just check like, oh, is this number bigger than 8? Is there some sort of trick though? I mean, maybe what you could do is and it, like take the and with all ones, well, that would just get you the same response. It would give you the same thing. Yeah, is there a better way to do it than linear? So what if I said and with 2 power 32 minus 1. So my output is 11. Yeah, so if you and it with all ones, then that's the same of not really changing it at all. Number of 1 bits. Okay. So let me try drawing the binary numbers here. Okay, so this is 0, 1, 2, 3, 4, 5, 6. So I'm wondering if it's some like weird division thing where we say if it's divisible by 2, then the number of ones goes up by 1. If it's divisible by, well, it's not really if it's divisible, right? It's more like if it has a 4 in it. But then we'd have to start all the way from the beginning. So I don't know why you couldn't just take the binary. Let me see what the recommended time and space is. Okay, O of 1 time and O of 1 space. Okay, that changes things. Yeah, so some things that are coming to mind is we could do length. So let me see what happens if I say the length of the binary of n. 6. I think that's because it's like 0b 1 0 1 1. Yeah, I don't really know. This might just be something that you have to look at the solution. O of 1, the number of ones in O of 1 time. Oops. Because let's say it could only be represented in 3. I would probably say, like, is it bigger than 4 or less than 4? If it's bigger than 4, then we know it I would say, like, number of ones plus equals 1. And I'd say, is it... Yeah, I honestly don't know how I do that. Well, something I notice is if it's even, it will have at least... So if it's even, we know that there will be 1 bit that is a 0, and if it's odd, there will be 1 bit that is a 1. In this case, it has a very, like, sort of like log n structure, because it's like split it in half, split it in half, split it in half. Yeah. I don't really know how to do it in O of 1. So I think I'll just call it here for the video. Yeah, I'm guessing it's just some operation. So if we have 0, 0, 0, I'm thinking if we AND it, it would give us 0, 0, 0. Maybe, well, this isn't the number. Is there just a function in Python or a built-in function that does it or something? If we XOR with the ones, then it would give us 0, 0, 0. If we have 0, 1, 1 and we XOR it with the ones, then we would get 1, 0, 0, which is 4. So this is 3, and then we XOR it with the ones, and it gives us 4. So maybe we could do like this minus that or something. Let's say we have 7, and we XOR it with the ones. Then we would get 1, 0, 0, 0, and that's 8. So 7 XOR like max equals 8. What if we had 6 and we XOR it with ones? Then that would give us 1, 0, 0, 1. So maybe we can use this number somehow. This gives us 9. So 6 XOR max goes to 9. And 9, so is it like 9 minus 6 plus minus 1? And then this would be 8 minus 7. Well, this is, it has 8 minus 7 plus 1. Yeah, I don't know if that's it. If we have 5, we XOR with the ones. Could it be, I mean, what does XORing with zeros do? That basically gives you the same number back. If you XOR with zeros, it gives you the same number back because, yeah. If you XOR with ones, it will basically give you the complements. If you XOR with the ones, it'll give you the complements. 1, 0, 1, 0. Does the complement help us at all? Like, so we're basically negating it. 1, 0, 1, 0. That would give us, so this is 5, goes to what, 10? I don't know if this helps us at all. Yeah, all right. Maybe it's just some operation like this, but yeah, I'm gonna call the video here. So thank you guys for watching. Today was day 62, so I'll see you guys tomorrow for day 63.